Okay, good morning. Today we are continuing with the square roots. We are on CO12. I can estimate the square root of a number and locate its value on a number line. So our last CO we were talking about those perfect squares. So square root of 25 we know is 5 times 5 equals 25. So the square root of 25 is just 5. But what do we do? So we know the area of the square is 25 yards. The measurement of each side would be 5 yards because 5 times 5 equals that 25. But now let's say the area of the square is 34 yards squared. 34 is not a perfect square. So how can we easily say what the measurement of its sides are? It is not so easy. So we need to taking the square root of a non-perfect square requires a strong understanding of your number sense and where those numbers fall on the number line. So let's examine some number sense by making a number line below. So thinking about that number line, here's 0. We know that 25, the square root of 25 was 5. So that I'm just going to put square root of 25. And we want to know the square root of 34. So we know 34 is bigger than 25. So the square root of 34 is going to be bigger than the square root of 25. We also know our next perfect square is 36. Square root of 36 is 6. So we can tell just by where these are falling on the number line, kind of an idea of where the square root of 34 is going to fall. It's going to fall closer to the 6 than to the 5 because 34 is closer to 36 than it is to 25. So that number in between 5 and 6 is going to be the decimal point. So it's going to be a decimal point probably close to 5.8. Now this is an estimate, so it's not going to be exact, but it's just getting an idea of where that number is going to fall. So an estimate of 34, we know that so it's going to be between 25, the square root of 25 and the square root of 36. So on that number line, it looks like it would be about 5.8 because it's bigger than 5, not quite as big as the 6. So that would be a good estimate.
One question.
Yes.
So what would if for 34 that estimated square root is 5.8, right? So
yes.
Will we just write 5.8 or with no label or something?
Correct. Okay. So like when we did the square root of 25, it would be just 5 because we don't have those measurements on it, so you don't need a label.
Okay.
So it would just be 5.8 would be your estimate. If you put 5.7, would it be wrong? No, because it's close. An estimate is close to it. If you put 5.2, I would say that's not as good of an estimate as you could get because we know that 34 is closer to 36. So it's going to be closer to that whole number of 6. So we want to try to estimate closer to the smaller number or closer to the bigger number as we're looking at it. So as we're doing this, you might want to refer back to binder page 24 where we had all of those perfect squares listed in that table. So our next square is the square root of 180. Well, if we look at our perfect squares, we know there's the perfect square of 169, which was 13, and the perfect square of 196, which was 14. So we need to ask ourselves, where does 180 fall in between 169 and 196? It's about midway. So it's kind of in the middle there, about midway. Let's see, there's 16 away here. And it is, well, it's only 11 away here. So it's going to be closer to that square root of 13. So it's going to be closer to our 13 because it's only 11 away. So it would be 13 point, closer to the 13 than the 14. So I would guess like 13.3. Again, it's not going to be exact. It's going to be close to it. So let's do another one. Square root of 5. So if we're looking back at the table on page 24, square root of 5, we know there's the square root of 4 and the square root of 9. So square root of 4 is 2, square root of, square root of 9, that was right, is 3. So on that numbered line between 2 and 3, 5 is closer to the 4, so it's going to fall closer to the 2. So it would be I would probably guess 2.1. So we just want to make sure that we're getting close to it. Square root of 68. Well, let's look back at our perfect squares. On this side, we have this perfect square of 64 and the perfect square of 81. So 64 is 8, 81 is 9. 68 is definitely closer to 64 than it is to 81. So I would guess probably like 8.2 because it's closer to that 64 than it is to the 81. So you always want to look, what are the perfect squares on each side of that non-perfect square that you're looking for, and think about what decimal it's going to get to. So let's scroll up.
So on the bottom would be the same thing.
Yep, so let me scroll up. And it says, estimate each square root to the nearest tenth and locate its value on a number line. Show your work. So you're going to be doing the same thing. You're going to be looking at that saying, what's the perfect square on the left of 94, which would be 81. Perfect square on the other side would be 100. So that would be between 9 and 10. So this is what you're going to want to write because it says locate its value on the number line. So draw your number line and then decide which side is it going to be closer to. 94 is only 6 away from 100, but it's 13 away from 81. So it's going to be closer to the 10. So you would say maybe 10.8. I'm sorry, not 10. Between 9 and 10. So between 9 and 10, it would be 9.8 maybe. Again, it doesn't have to be exact. It could be 9.7, but it's the estimate. So you want to be close. You're not going to guess that it's going to be 9.2 because it is a lot closer to 100 than it is to 84. So you want to make it the best educated guess that you could get. So if we look at square root of 10, we know on one side it's the square root of 9. The next one would be the square root of 16. So you would have 3 to 4. 10 is closer to 9, so it's going to fall closer to the 3. So it would be 3.2, 3.1, 3.2, somewhere in there, because we want it to be closer to the 9. So it's going to be closer to the 3. I'm going to let you do the rest on your own. You do have page 26 also to work on. So remember, when it says locate its value on the number line, you're going to want to write it out, just like I did here. You can put your perfect squares next to it. So you can see, is it closer to the left or closer to the right? So if it's closer to the left, you want it on the number line to be closer to the number on the left. If it's closer to the square root on the right, you want it on the number line to be closer to the number on the right. So it's not going to be exact and perfect, but you can get close. So let's stop recording.